How's it going, guys? Today in this video, we're going to be going over the Module 11 test review or the final review. So I'm going to start every other video. We do have the completed key on Canvas already, completed chapter notes, module notes, and on Canvas as well. So they're also great resources to kind of help brush up on some of these old topics. But other than that, we're going to go ahead and get started. So number one, we're told to find the inverse of each function, confirm using composition, and graph each function and its inverse. So anytime that we're trying to find the inverse of a quadratic or a polynomial to the second degree, we always have to restrict this domain. Right? I don't want to get too much into why we have to do that, but just remember on the final, for our purposes in this class, anytime you see something that says restricted domain, just put x is greater than or equal to 0. All right? So restricted domain for a quadratic in this class, it will always be x is greater than 0, greater than or equal to 0. And now we need to find our inverse. So to find the inverse, what we're going to do is first we have the function f of x equals x squared minus 3. We're going to change it into y equals x squared minus 3. And now we're just going to switch the variables y and x. There's no math involved in this step. We're just changing what each variable is, where they are. So instead of y equals x squared minus 3, it's now x equals y squared minus 3. And then from here, we just solve for y. X plus 3 equals y squared. And then we take the square root of both sides to get rid of that square on the y. We get the square root of x plus 3 equals y. And we can rewrite y as f inverse of x equals the square root of x plus 3. And that's our inverse function. All right, so just switch the x's and y's, solve for y again. That's your inverse function. And now we're going to confirm with composition. So remember, composition is we need to make sure that f of the inverse of x equals x. We also need to make sure that the opposite of that, the f inverse, there we go, f inverse of f of x also equals x. So we need to make sure both of these are true. So for the first one, in green, we want the function in terms of the inverse, and we said the inverse is the square root of x plus 3, and this needs to equal x. So what this means is we want the function, the f of x function, this one right here, in terms of x plus 3, which means just replace the x with the square root of x plus 3. So we get the square root of x plus 3 squared minus 3 needs to equal x. The square root and square cancel out. X plus 3 minus 3 has to equal x. Plus 3 minus 3 gives you 0. X equals x. That's exactly what we wanted. And now for the f inverse of f of x. So that's going to be f inverse in terms of f of x. And f of x we said is x squared minus 3. And that needs to equal x. So what that's saying is that we want the inverse function, which is what we found down below. We want to put that in terms of x squared minus 3, or we're going to replace each x in the inverse function with that x squared minus 3. So we have the square root of, instead of x, we're going to put x squared minus 3. It was way too big of a square root. X squared plus 3, sorry, minus 3 should equal x. All right? There we go. So replace the x in the inverse function with x squared minus 3. You get the square root of x squared plus 3 minus 3. Plus 3 minus 3 is 0. We're left with the square root of x squared. The square root and square cancel out. And we get x equals x. That's exactly what we wanted. So we confirm that it's a composition. All that's left to do now is to make our table and graph our function. So to make our table, all I'm really going to do is make my f of x table, and I'll make my xy table, and my f of x function is x squared minus 3. I'm putting that down there just to kind of remind me what it is, so I don't have to keep scrolling back up. And now I'm going to choose 2 or 3 or 4 x values to plot my points. But remember, for f of x, in the very beginning, we restricted our domain. to be greater than or equal to 0. So we do not want to choose any negative x values. We only want to choose x values greater than or equal to 0. So I'm going to start with 0 because it's pretty easy to do. Plug it in. You get -3. Same thing with 1. 1 squared minus 3 is -2. And then we plug in 2. We get 4. 2 squared is 4 minus 3 is 1. So that's my f of x function on my f of x table. And to plot that, I have 0, -3. We don't really have that. They'll be about right there. 1, -2, about right there. And then 2, +1, right around there. So our function will look something like that, like half a quadratic, because that's exactly what it is. We restricted the domain at the vertex, so it is half of a quadratic. And now for f inverse of x, we don't really care for writing out the function in this one, because the inverse table is going to be the opposite of the f of x table, because the inverse and f of x, the difference between them is you're just flipping the x's and y's. That's exactly what an inverse is. You flip the x and y terms to get your new function. So what that means is instead of 0, -3 on the f of x table, we're getting -3, 0. Instead of 1, -2, it's -2, 1. And instead of 2, 1, it's 1, 2. All we do is flip the x's and y's to get our inverse function. So we have -3, 0. That'll be about right there. -2, +1, right around there, and then 1, +2, right there. Our function will look like that. And it looks just like a square root function because it is a square root function, and so we know we graphed it right. All right, so that's number 1. Let's keep on going. Number 4. So we're told the function r of v equals the cube root of 3v all over 4 pi, models the radius rv of a sphere as a function of the volume v of the sphere. So for A, that asks us to find the radius of the famous in Walt Disney World, Florida. The volume is 716,280 meters cubed. That's worded really weird, but what I think it's trying to say is find r when our v is 716,280. So we have r of v equals the cube root of 3v over 4 pi. So we have our volume of 716,280. We'll plug that in. So r is going to equal the cube root of 3 times 716,280 divided by 4 pi. And from here, we're just going to plug this to the calculator. We can't really do anything more by hand over here. So plug it into a calculator, and when you do, you should get approximately 55.4. So that's what our radius is going to be, 55.4 meters. All right. Now for 4b, we're told to find the inverse of the function. So if we find the inverse of the function, we have r of v equals the cube root of 3v over 4 pi. So the inverse of a function is when you put the whole function in terms of the other variable. So when we do that here, we have our r variable. That's what it's set equal to. Is r equals whatever the function is. Now we want to change this into v equals, because putting this in terms of the volume equals in terms of the radius, that's going to be the inverse function for this problem. Or in other words, we have rv equals. You want to set this to v of r equals whatever it is. Whatever it is, we're going to figure out. So that's what we need to do to find r inverse. So we have r equals the cube root of 3v over 4 pi. We're just rewriting it without the parentheses of v. Now we're going to cube both sides, so you can get rid of that cube root. So r cubed equals 3v over 4 pi. The cube root and cube cancel out. Multiply by 4 pi on both sides. So 4 pi r cubed equals 3v. Then we divide by 3 to get 4 pi r cubed all over 3 equals v. And that's going to be our inverse function. All right? So that's our inverse function. And now let's go see what 4c is asking us to do. what does the inverse represent? So the inverse, that represents volume of the sphere given the radius. So it gives you the volume given radius. All right, so I'm basically saying if I have my radius, I can find my volume. That's what it's saying. Estimate the volume of the reflecting sphere from the famous print hand for the reflecting sphere MC. Eschers, if the radius is 9 centimeters. I think that's supposed to be 9 meters. I'm not sure. But anyway, we're going to do it. I think basically what it's saying is find the volume given that the radius is 9. That's what I'm going to do anyway. I'm going to solve it as, that's what I'm going to do. I think it's really worded. It's a very weirdly worded problem. There we go. So I'm just going to solve this as r is 9. So v equals 4 pi, 9 cubed, all over 3. And that's what the key does anyway, so that's what we're going to do here as well. So for D, it gives us our radius of 9 centimeters instead of 9 meters, whatever. We're going to do it with this formula here. We're going to solve this out. So at this point here, there's nothing we can really do by ourselves anymore. This is something you put into your calculator. And when you do, you should get 3,053.6 centimeters cubed. And that's what your answer is. But the biggest part here is just to know that you have our inverse function, and our inverse function gives us our volume in terms of the radius. So if we have our radius, we can just plug that in, plug in our r, and it gives us our v. That's basically the point of 4D, despite it being worded really weird. All right? Let's keep on going. On to number 6. We're told to find the transform reference point in graph, describe the domain and range using set notation. So first we need to do is find the domain. So a domain, well before that, actually, let's go ahead and find our A, B, H, and K. I think that's always worth finding first. Our A is 2, our B is 1, our H is 3, and our K is -2. So find our domain. Our domain, when it comes to square root functions, is always going to be x such that x is greater than or equal to our h. So in this case, x such that x is greater than or equal to 3. That's because the h value is the term of our first point in the graph. So if a is positive, it's x such that x is greater than or equal to h. So in this case, x is greater than or equal to 3. All right, there's other properties too. Since if a is negative, it'll be x is less than or equal to h. So, or sorry, b is negative, it happens like that. But go over your properties in the completed notes to figure that out. All right, to review it. And our range, same thing. Since our a is positive, it's y such that y is greater than or equal to -2. And this is going to be in the form y such that y is greater than or equal to k, because a is positive. So if a is positive, then your range is going to be y is greater than or equal to k. A is negative, then will be y is less than or equal to k. Again, go to the completed packets module. We have it all online right in the front. Go over it if you need to go over the rules of what happens with these functions. All right. So we need to figure out our transform points. So remember, our transformation rule is bx plus h, comma ay plus k. This is incredibly important. So make sure you have this memorized. So bx plus h will give us x plus 3. Then ay plus k is 2y minus 2. And our 2 points we're going to transform are 0, 0 and 1, 1. We just plug these into our transformation rule. So 0, 0 into our transformation rule gives us 3, -2. And then 1, 1 is 4, 0. So those are our 2 points. So we're going to go ahead and graph them now. So we have 3, -2 will be about right here, and 4, 0 right here. So our function will look like that. All right. So let's keep on going. Next, we're on number 9. Write the function that matches the graph using the indicate transformation format. So we want to figure out what this function is going to be in terms of a. So when we have our a, we're not solving for our b. So what we're going to do is, or something we need to know, is that this leading point right here, the point that starts the whole square root function, that's always going to be in the form h comma k. So if we know that point, we know our h and k. So this point is -3, +5. So it means our hk point is -3, +5. And all that's left now for us to solve for is our a. So if you plug in everything we have here, we have some g of x, or really our y, equals a times the square root of x minus -3, or x plus 3 plus 5. So all we're missing now is an x and a y term to figure out what our a is going to be. And they gave us another point on this graph, which is -2, +2. So we can plug that into this g of x that we just made to figure out what our a value is going to be. So it's -2, +2. So our y value is 2. So 2 equals some a term we don't know, times the square root of our x value of -2, plus 3, plus 5. So we're going to work this out for a. 2 equals a times the square root of 1 plus 5 minus the 5 over. -3 equals a. Square root of 1 is just 1, so our a is -3. So we plug that back into our function. So this function is g of x equals -3 times the square root of x plus 3 plus 5. So remember, when you're writing your answer to this problem, you do not put the g of the x and the y term we found over here. You only put in the h, k, in the a or b, whatever you're asking yourself for. All right, do not put in the x and y. It's not going to be right because they're only giving us an equation to one number. It's not going to be right. You need to put the y and the x as variables. All right. So let's keep on going. Number 13. The data represents the population P in thousands of a certain town at time t in years. After the town is founded, a model for the situation is P of t equals 2.8 times the cube root of t. So what we're going to do is we need to figure out what our table is going to be first. So we're going to fill out these terms. So we plug in 0 into x, you get, or into t, sorry, you get 0. You plug in 2, you'll get about 3.5. You plug in 4, you get about 4.4. Plug in 6, you get 5.1. 8 gives you about 5.6. And 10 gives you 6.0. All right, so we're rounding to the 10th place. Plug in your x values into your p of t. So I keep saying x values because it says x on the table, but it's really our t terms. So this really should say t and p of t. That's more correct. So plug in your t terms into the function of p of t. That gives you your p of t terms. And that's how I fill out the rest of this table. So what we're going to do now is we're going to plot these points. So we'll have one at 0, 0, one at 2, 3.5, right around here. Or no, right there, it's 3. 3.5 will be a little more higher up, right about there. 4, 4.4. So let's say about right here. 6, 5.1. So right there. 8, 5.6. Right around there. And 10, 6.0, right there. All right. So our function will look something like that. And now we need to figure out our average rate of change. So average rate of change, remember, it's, you think real quick. All right, sorry, I blanked out for a second, but y2 minus y1 all over x2 minus x1. There we go. All right, so that's our average rate of change formula. Average rate of change is also our slope formula. So if you remember from back in Algebra 1, it's the same thing. So our first interval that we need to find, that's going to be the rate of change from 0, 0 to 3.5. That's the first interval between 2 points. That's the average rate of change we need to find. So if we plug in our terms, y2 is 3.5 minus y1, which is 0, all over x2, which is 2 minus 0. So basically 3.5 divided by 2, which is about 1.5. 0.75. Next, the second interval, that'll be from the second point to the third point. So same thing, we're going to plug in our terms. Y2, which is 4.4, minus Y1, which is 3.5, all over 4 minus 2, which gives us about 0.45. And then for the third interval, we go from 4.4 to 6, 5.1. So Y1, 5.1 minus 4.4, all over x2 minus x1, so 6 minus 4. That gives us about 0.3 or 0.35. So let's write that. All right, so you get about 0.35. So now we're asking, is the average rate of change, is it becoming bigger or smaller? And it's becoming smaller or less. We can see as we go up in intervals, the average rate of change is getting smaller and smaller. So the average rate of change is becoming less. And after how many years is the population of the town 8,000? So we're looking at about when our term is about at 8,000, it's going to be about 23.3 years. And the way that we find that is that we're told for this problem that the data represents the population P in thousands. So that means the P is in terms of thousands. So it's not going to be 8,000 equals, it's going to be 8 equals 2.8 times the cube root of T, because we're saying the P is in terms of the thousands. So this 6.0 we have for 10 is actually going to be 6,000. All right. So that's what it means. Each certain unit is going to be into the thousands. So 6 is going to be the same thing as 6,000, because 8 is the same thing as 8,000. So we're going to solve it out. So 8, we're going to divide each side by 2.8. And 8 divided by 2.8. Let's figure that out. That's about 2.857. So 8 divided by 2.8 is, let's say, about 2.85. That's going to equal the cube root of T. We're going to cube both sides. And when you cube both sides, you get that T is approximately that 23.3 that we found. So that's how you find it. Just because the problem says the data represents the population P in thousands, that means that this population 8,000 is really going to be an 8 in the problem. So that's how you plug it in, and that's how you're going to find that 23.3. All right, let's keep on going. Number 15, graph the cube root functions. Recall the transformation rule, bx plus h, ay plus k. You should know that. It's very important. So what we're going to do first is we're going to figure out our transformation rule. So our a, b, h, and k, I'm going to do that on the side. A is 2, b is 1, h is 1, and k is 3. So we plug that into our transformation rule. Our b is 1, so we have x plus 1, comma ay plus k. So 2y plus 3, that's our transformation rule. And now we're going to transform each of these points by plugging in the x and y value into these points, into the transformation rule, sorry. And when we do, you'll get that -7, comma, -1, 0, positive 1, 1, comma 3, 2, comma 5, and 9, comma 7. So that's how you figure out your rules, or that's how you figure out the transform points. And all you really do is just figure out your transformation rule. That's the most important part. And then plug everything into, or plug in all your parent function points into that transformation rule to figure out your transform points. So now, list of transformations. So this A tells us it's a vertical stretch, so VS for short, by 2. This B tells us nothing really. This H tells us it's a horizontal shift, so horizontal shift to the right by 1. And then K tells us it's a vertical shift down, sorry, not down, by up by 3. So vertical shift up by 3. All that's left now is to graph our new function. So you have -7, -1, so we're right around there. 0, 1, 1, 3, 2, 5, and 9, 7, right around there. So our graph will look something like that. So that's how you graph a cube root function, transform the points by putting them into the transformation rule that you should have memorized by now. Bx plus h comma ay plus k. We've been talking about it, been harping on it since the beginning of the year. You need to have that memorized. It's important for all the functions in this final. But other than that, that's how you do the problem. That's how you graph it. Let's keep on going. Number 18, write the function in the form t of x equals a times the cube root of x minus h plus k. So our initial point is going to be the -2, +5. Or sorry, -2, -5. That's to be kind of the point that's in the most vertical part right here. So -2, -5 is the most vertical part. And the other point they gave us is -1, -3. That's just one other point. You can use the other one too if you wanted to, which is 6, -1. It doesn't matter. But -1, -3 is just smaller numbers. It makes it a little easier to solve for. So we're going to solve this out. This right here gives you your x and y, while this gives you your h and k. So we can plug these into our formula. G of x, or rather our y, so we can put that in as well. Our y is -3. That equals some a term that we don't know, times the cube root of x minus -2, or x plus 2, minus 5. I'm not sure how to put x. Just rewrite that. We have our x of -1. So it's, I'm not sure why it's there, but it's -1 plus 2 minus 5. We're going to figure that out. -3 equals a. The cube root of -1 plus 2 is just 1 minus 5. Add 5 over. You get 2 equals a times the cube root of 1, which is just 1. So our a just equals 2. We'll plug that in. So g of x equals 2 times the cube root of x plus 2 minus 5. And I think that's the last problem of the video, guys. It is. Like I said, if you need extra help with any of the problems, we do have all the completed notes on Canvas, so you can go over that as well, just extra problems. The textbook should be online and accessible for you guys, so that should give you some extra problems to do as well if you need the review. Other than that, guys, hopefully this video helped.